The focus of this video lesson is using parallelograms in the coordinate plane. Example 1. Find the coordinates of the intersection of the diagonals of parallelogram LMNO with vertices L at 1, 4, M at 7, 4, N at 6, 0, and O at 0, 0. We're going to start by plotting the points. L is at 1, 4. M is at 7, 4. N is at 6, 0. And O is at 0, 0. The question we're trying to answer is, what are the intersection of the diagonals of this parallelogram? This is our parallelogram. Now note, we can actually find the intersection of the diagonals without actually drawing the diagonals. So let's start with that. If we look at this, we'll notice that here is our L, M, N, and O. We know, according to the theorem learned yesterday, that the diagonals of a parallelogram bisect each other, meaning the line from L to M will be cut in half by the diagonal that's drawn from M to O. So even without drawing those diagonals, we should be able to calculate our answer. So let's take a look. The diagonal from L to M is going to be bisected, meaning it's going to be cut in half, meaning we need to find the middle of the points 1, 4, and 6, 0. If we think back to the first or second week of geometry, we know that the midpoint is given by adding the x's and cutting in half, and adding the y values and cutting in half. So let's go ahead and do that for L and N. Our midpoint is given by 1 plus 6, those are our x values, cut in half, comma, y values, 4 plus 0, cut in half. So that gives us 1 plus 6, which is 7 halves, 4 plus 0, which is 4 halves, which then turns into 3.5, comma, 2. So then we know that our midpoint is going to be located at right 3.5 up 2, right here. Now if we actually draw our midpoints, we will see that. And that's it for example 1. So note, we can do it graphically, but as finding the intersection of the diagonals is as simple as finding the midpoint of opposite vertices. Now it's your turn to try. Find the coordinates of the intersection of the diagonals for parallelogram ABCD with vertices at 1, 0, 6, 0, 5, 3, and 0, 3. Start by graphing it. Use the midpoint formula to find the intersection of the diagonals and then test it by drawing the diagonals and verifying. Pause the video and give it a try. All right, example 2. 3 vertices of parallelogram W, X, Y, Z are W, -1, -3, X, -3, 2, and Z, 4, -4. Find the coordinates of vertex Y. Let's start by plotting the ones we know. W is at -1, -3. X is at -3, 2. And Z is at 4, -4. Now we know that this parallelogram is W, X, Y, Z, and in that order. So W, X, what do we got? W right here, -1, -3. X, -3, 2. Y is somewhere over here to the right, and then Z. So we're going to go up, right, down, and around. So we know that our Y is located over here in the first quadrant. Now, in order to figure that out, we need to understand the relationship between the sides of a parallelogram. I know that in a parallelogram, that the opposite sides are parallel. If I look over here on my first side, the side connecting these two bottom points, I can see that this side has a slope of down 1 over 1, 2, 3, 4, 5. Now remember from before that parallel lines have the same slope. I know that there must be an opposite side, opposite here, that also has this slope down 1 over 5. So I'm going to go up to this point, x. I'm going to go down 1 and over 1, 2, 3, 4, 5, and that tells me the location of my point y. Connecting the points, I see that that is in fact my parallelogram. So our coordinates for y are 2, 1. Now it's your turn. Give it a try. 3 vertices of parallelogram ABCD are 2, 4, 5, 2, and 3, -1. Find the coordinates of vertex D. Pause the video and give it a try. Once you have this finished, go ahead and jump into Delta Math. Find the practice assignment titled Coordinate Planes for Parallelograms.